Multiplying radical expressions is what we're going to be looking at today. So let's get to looking at it. Example number 1 here. It says the square root of 4 times the square root of 25, and you all are fairly capable of saying the square root of 4 is 2 and the square root of 25 is 5, and then 2 times 5 is 10. But when we have radical expressions, we can also multiply them inside those radical expressions. You notice here that the index is 2 for both of these. It's the invisible 2 for radicals there. So it's the square root of 4 times the square root of 25. And so basically what you do is since they're both square roots, you use the square root symbol. And then 4 times 25 is 100. And then what's the square root of 100? That would be 10. Okay, I showed you that simple example to help you out, help you get started here. Looking here, we have a cube root, we have a cube root. So therefore, our answer should be a cube root. And what is 9 times 3? Well, that's 27. Can't we simplify the cube root of 27? Well, in this case, it actually simplifies down to 3. The cube root of 27 is 3. So we have a couple simple ones there to get you started. Now let's look here. If we are to multiply all 3 of those numbers, what are we looking at? Well, we're looking at that. Well, they're all the 5th roots. The 5th root of 3, the 5th root of 27, and the 5th root of 9. So what can we do? Well, look at 3, look at 27, look at 9. They all are special because I guess we could say 3 times 27 times 9, but as far as 3 times 27, I know that's 81, and 81 times 9 is a rather large number. I think I have that one in my head already, but I'd like to show you something else that you could do, because finding the 5th root of 81 times 9 is 729, I believe. But to find the 5th root of 729 is a little bit of a challenge. But look here, if we have negative 2, 5th root of 3 to the 1st power, times 3 times the 5th root of, well, 27 is 3 cubed. And what is 9 as far as 3 to what power? 3 squared. And so, let's put that off to the side. So now we have a 5th root, we have a 5th root, we have a 5th root. Let's have a 5th root here. Well, if we have 3 to the 1st power times 3 to the 3rd power times 3 to the 2nd power, and then look at these numbers, 2 times 3 times 2. Negative 2 times 3 is negative 6, and then times 2 again, that would be negative 12. What's underneath this 5th root? We will have 3 to the, well, 1 plus 3 is 4, plus 2 is 6. 3 to the 6th power. Can we simplify that a little bit? Well, if we have 6 of them inside, and we need to pull them out in 5s, that means we will pull 5 of them outside, leaving us with 1 of them inside. Because there were 6 in there total. If we pulled 5 out, that leaves 1 left over. And now what is negative 12 times 3? Negative 36. And yeah, that's where we're at. And that's the simplified form. I can tell you working with 3 to the 6th power was a lot simpler than working with 729. And so you have to be able to utilize what you know about perfect squares, perfect cubes, and those type of numbers. Even though there's variables in there, it's still done the same way. They're both square roots, so your answer will be a square root. And x to the 10th times x to the 6th is x to the 16th. Now here's the thing, it's a square root, so we have to pull them out in pairs, right? In groups of 2. So how many pairs of x's can you pull out? You can pull out 8 pairs. And so x to the 8th power is the solution there. And this one here, we just put numbers and variables together. They're both cube roots, which is a good thing. So we know our answer is going to be in a cube root. And 3 times 9 is a fairly simple number to multiply. It's not like 729 like we was working with earlier. 3 times 9 is 27. X to the first times x squared is x cubed. Oh, that's exciting because we're going to be able to pull that x out. And then y squared times y to the 4th is going to be y to the 6th, which is even more exciting because there's 2 pairs of y's coming out. Or I'm sorry, not 2 pairs of y, 2 triplets of y's coming out. Alrighty, the cube root of 27 is 3. There are no numbers left inside. How about x cubed? Well, if we take and how many triplets of x's can you bring out? You can bring 1 triplet out. None of them will be left inside. And then how about y's? How many triplets of y can you bring out? You can bring out, and you know that I'm getting this 3 from here. Our index lets us know. So how many y's can we bring out? Bring out 2 of them and nothing left inside because 6 divided by 3 is 3 goes into 6 evenly. And so we have simplified that expression. And I think we have one last one. Oh, I wrote that one in invisible ink. Good luck solving that one. That's all we have for this. If you have any questions, I'll see you next time. You can ask them then.